Welcome to a lesson on how to use the second derivative test to determine relative or local extrema. If we let f of x be a function with a critical value or a critical number of x equals c, if f double prime of c is greater than 0 or positive, then f of x is concave up at x equals c, and f of c is a relative minimum. So again, if x equals c is a critical number, and the second derivative is positive at x equals c, then f of x is concave up, and therefore we must have a low point at x equals c, and therefore f of c is a relative minimum. And if f double prime of c is less than 0 or negative, f of x is concave down, and f of c is a relative maximum. So again, if the second derivative is negative or less than 0 at x equals c, then f of x is concave down, and therefore we must have a high point on the graph at x equals c, and therefore f of c is a relative maximum. And if f double prime of c equals 0, the second derivative test is inconclusive, and therefore we'd have to analyze the graph or use the first derivative test. Let's look at an example. Here we're asked to determine any relative extrema using the second derivative test. Well, the first step is to determine the critical numbers or critical values, which are where the first derivative is equal to 0 or undefined. So let's begin by determining the first derivative. F prime of x is equal to the derivative of negative 6x to the fifth plus 10x cubed, which is equal to negative 30x to the fourth plus 30x squared. Well, there are no values for x where the first derivative is undefined, and therefore to find the critical numbers, we set the first derivative equal to 0 and solve. Let's see if we can solve by factoring. Notice here the greatest common factor is 30x squared. Let's factor out negative 30x squared. If we factor out negative 30x squared, we have negative 30x squared times the quantity x squared minus 1. Notice if we distribute, we still have negative 30x to the fourth plus 30x squared. From here, notice x squared minus 1 factors further because we have a difference of squares. We have negative 30x squared times the quantity x plus 1 times the quantity x minus 1 equals 0. And now we know the first derivative is equal to 0 when x equals 0, x equals negative 1, and x equals positive 1. F of x has 3 critical numbers. Let's go ahead and record these above. I'm going to go ahead and list them in order from least to greatest. We have negative 1, 0, and 1. And now we're going to find the second derivative and then determine the sign of the second derivative at the critical numbers. So going back up to our first derivative, let's now find the second derivative. The second derivative is equal to the derivative of the first derivative, or the derivative of negative 30x to the fourth plus 30x squared, which is negative 120x cubed plus 60x. Again, now we need to determine the sign of the second derivative at the 3 critical numbers. We need to determine the sign of f double prime of negative 1, f double prime of 0, and f double prime of 1. F double prime of negative 1 is equal to negative 120 times the cube of negative 1 plus 60 times negative 1. Simplifying, we have the cube of negative 1, which is negative 1. Negative 120 times negative 1 is positive 120. And then plus negative 60, or just minus 60, which equals positive 60. So because f double prime of negative 1 is greater than 0 or positive, the function is concave up at x equals negative 1. So if the function is concave up at x equals negative 1, and negative 1 is a critical number, we must have a low point at x equals negative 1, and therefore f of negative 1 is a relative minimum. So for our notes below, let's state we have a relative minimum of f of negative 1. We'll come back and find this exact function value in a moment at x equals negative 1. And now let's determine the sign of f double prime of 0, which is negative 120 times the cube of 0 plus 60 times 0. Well, this results in 0, and therefore the second derivative test is inconclusive. Which means we'll have to determine whether we have a relative extrema at x equals 0 by analyzing the graph or using the first derivative test. And now let's determine the sign of f double prime of 1. F double prime of 1 is equal to negative 120 times the cube of 1 plus 60 times 1, which is equal to negative 120 plus 60, which equals negative 60, which is less than 0. So because the second derivative is less than 0 or negative at x equals 1, we know the function is concave down at x equals 1. So if the function is concave down at x equals 1, and x equals 1 is a critical number, we must have a high point at x equals 1, and therefore f of 1 would be a relative maximum. So again, for our notes below, we'll say we have a relative maximum of f of 1, which we'll determine in a moment at x equals 1. And now let's determine f of 1 and f of negative 1. F of 1 is equal to negative 6 times the fifth power of 1 plus 10 times the third power of 1, which is equal to negative 6 plus 10, which is equal to positive 4. So now we know we have a relative maximum of 4 at x equals 1, and now let's also determine f of negative 1 to determine the relative minimum. F of negative 1 is equal to negative 6 times the fifth power of negative 1 plus 10 times the cube of negative 1, which is equal to, the fifth power of negative 1 is negative 1 times negative 6, which is 6, and then plus the cube of negative 1 is negative 1, so we have plus negative 10 or just minus 10, which equals negative 4. So the relative minimum is negative 4. Now remember, the test was inconclusive at x equals 0, so we'll analyze the graph to determine whether we have a relative max, a relative min, or neither at x equals 0. Analyzing the graph, notice how we do have a relative minimum of negative 4 at x equals negative 1. We also have a relative maximum of 4 at x equals positive 1. And notice how we don't have a relative max or min at x equals 0 because we don't have a high point or low point at x equals 0, even though the slope of the tangent line is 0 at x equals 0. So the graph does verify our work is correct. I hope you found this helpful.